comparing collectives. So in this exercise, now that we've run and downloaded, compiled, and run simple ASTRA-sim script, I will let you know more advanced scripts using ASTRA-sim, and then using it, compare various ASTRA-sim collective communication results and different topologies as well. So last exercise, we run 1 megabyte all reduce on a 8 size ring. Now let's assume we want to run 5 megabyte all reduce. The most straightforward and easy way to do it is, of course, go into the workload info file and change the size to 5 megabytes. But if you want to test 10 megabyte, 20 megabyte, like 1 gigabyte every time, creating this network info file is very tedious. That's why instead of changing any input file, we offer this configuration called communication scale whenever you run ASTRA-sim. If you set this to 5, it will automatically scale the communication size to 5x. So with just 1 megabyte workload input file, yet setting this communication scale to 5, this is effectively just testing 5 megabytes or reduce. So by doing this way, you don't need to change any file. Then this is another feature, executing multiple ASTRA-sim instances and yet collecting the result in one single CSV file. So to do that, whenever you call ASTRA-sim, you designate this number, total stat rows, which is nothing but in a single CSV file, how many rows you want to store. Here, the example, we are running 1, 5, and 10 megabyte all reduce. So we are running 3 ASTRA-sim simulations. That's why I set it to 3. Then per each unique instances, I just give them the stat row starting from 0. So this is nothing but first running calling ASTRA-sim with 1 megabyte all reduce with row 0, then running 5 megabyte all reduce with index 1, then finally running 10 megabyte all reduce with ID 2. By doing this, this will create just one CSV log, and without changing any input file, you're still able to run multiple ASTRA-sims. So the exercise here is to run various size all reduce on the same topology 8 size ring, ranging from 1 megabyte up to 1 gigabyte in total 11 configurations. And to do that, we don't have to change any input file. We can just create a for loop in the script, and this for loop automatically iterates over the sizes defined here and calls ASTRA-sim. And as you can see here, I designated the total stat row to 11 and changing the ID of each row as well. So this will just create one single CSV file that's having all the input, that's having all the run results. So we have already generated this this run script as well. So what you can do is just go to exercise 2 folder, run the ASTRA-sim again, build the ASTRA-sim again, and just call this exercise 2.1 shell script. This will just run the for loop and run all ASTRA-sim. So I'll do the very same thing here. I'll go to the previous tree, then go to exercise 2, then run exercise 2.1. And this running ASTRA-sim, and it finished running the 11 configurations. Then you can see the result here. Exercise 2, if you go to this result 1 folder, here we have, it dumps a lot of logs, but of course this tutorial results. And if you open the CSV file, here as you can see, all the 11 run is dumped into one single CSV file because we designated to do it with the ASTRA-sim run configurations. So going back to the slide, this is the result I just copy and pasted. Again, because this is simple communication test, there's no compute time, and the exposed communication time grows as the ASTRA-sims, as the collective size increases. And when I do the graph, the communication time and the all reduced size, we just find out it has linear relationship. So these kind of experiments can be done very easily using ASTRA-sim and simple scripts. Then at the analytical backend for now doesn't only support ring, it also supports other topologies like switch and fully connected. So this is another exercise of just writing more input scripts, input files. So the shown one left is switch topology. And on switch topology, the best topology or collective algorithm is halving, doubling, all reduce. So we're going to use it. And again, like if you zoom in those purple MPUs, each MPU is using one outgoing link to the switch. Whereas the fully connected one shown right is the best collective communication algorithm on it to use is direct all reduce. And because it's fully connected, when there's n MPUs in total, the number of links going out from each MPU is n-1. So again, using the same information, we create the network input file for both switch and fully connected. So the changed one is shown here. The topology name becomes switch and fully connected. And it still has 8 GPUs, but the number of links, the switch one has only 1 link per MPU, and the fully connected one, because there's 8 MPUs, have 7 links going out. But still, I set the link characteristics the same. So each link has 500 nanoseconds link latency and 50 gigabytes per second link bandwidth. Then again, like I just created the corresponding system info file as well. I changed nothing, but I changed the all reduce collective communication algorithm to halving, doubling, and direct algorithm because they are best suitable for collective algorithm for both topologies. So now the objective is now we have 3 different topologies, ring, switch, and fully connected. I will run 1 gigabyte all reduce on it and compare their results. So it's again very simple. I just set this total stat row to 3. And for each and every different ASTRA-sim instances, I just give the different stat row. For switch, I mean here I'm just only showing the switch. The stat row is 1. And the communication scale is 1024. So this is automatically testing 1 gigabyte all reduce. So the run script is already again offered by in the same folder as exercise 2.2. So I will go and run it. So it's here. I will run exercise 2.2 script, and it run 3 ASTRA-sim instances. And you can also check the results in this folder, result 2 tutorial results. And I just copy and pasted the CSV number here. Again, still this is just communication test, so no compute time reported. And but the communication time is different. Fully connected was having the fastest collective performance because it just has the most number of links per each GPU. It had like 7 links. Whereas ring had 2 links per MPU. And finally, the switch only had 1 link per MPU. That's why it showed this lowest performance.